Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. We got a piston cylinder device holding 100 kilograms of refrigerant R-134a at 200 kPa, a volume of 12.322 meters cubed. The volume is halved when the piston is moved. It remains constant pressure. Find the final temperature and the change in internal energy. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. We got a piston cylinder device. We've got the refrigerant. We got the initial pressure that is constant throughout the process. The mass, which is 100 kilograms, and the volume of 12.322 meters cubed. Step 2, list all the given variables, find the unknown. We want to find the final temperature and change in internal energy. Step 3, find the temperature at 200 kPa. We need the specific volume, and then go to the property table and compare. Step 4, find the final specific volume formula. So little v final is the final specific volume. So it is the initial specific volume divided by 2 because it's halved when it reaches that point. Step 5, find the initial specific volume formula. Initial specific volume is little v initial is equal to the actual volume divided by mass. So capital V divided by M. Step 6, find the initial specific volume. So we just plug and play. Both of these values are given in the question. So we get 0.12322 meters cubed per kilogram. Step 7, find the final specific volume. So we just divide by 2, so that becomes 0.06161 meters cubed per kilogram. Step 8, find the final temperature. Go to your property table, use the pressure table because they give you 200 kPa. We're going to compare the final specific volume with the property table. So it is in between saturated liquid and saturated vapor. It's a saturated mixture, so that means we can use the saturated temperature. So the final temperature is minus 10.09 degrees Celsius. That's the answer for part A. Moving on to part B. Step 9, find the change in internal energy formula. So delta little u is equal to little u final minus the little u initial. So that is the internal energy final minus initial. Step 10, find the final specific internal energy formula. So that is little u initial is equal to UF plus the final quality multiplied by UFG. Both of the internal energies are at 200 kPa. So we're going to find the final quality first. So we're going to find the formula, step 11. So X final is equal to the final specific volume minus VF at 200 kPa divided by VFG. Step 12, find the specific volume evaporation formula. So VFG is equal to VG minus VF. Step 13, find the final quality. So we're just going to plug and play from using the property table. So we got VF and VG. So the final quality is 0.613489. It's unitless, the units cancel out. Step 14, find the specific saturated liquid and evaporation internal energy. So that's UF and UFG. That is also in your property table. Step 15, find the final specific internal energy. So we got all these values. We're just going to plug and play. So the quality is found in step 13. And and the UF and UFG is found in step 14. So the final specific internal energy is 152.52 kilojoules per kilogram. Now we need to find the initial internal energy. So the initial specific volume is 0.12322 meters cubed per kilogram from step 6. And then we compare with the property table. So this value is greater than the saturated vapor, so that means it's superheated vapor. Step 17, go to the superheated vapor table, use your pressure, 200 kPa, so that's 0.2 MPa, and then your specific volume, line them up and match to find your internal energy. Step 18, find your change in internal energy. So you have the final minus the initial. Your change in internal energy is minus 110.6 kilojoules per kilogram. Disclaimers, the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. You can do this by using Snipping Tool. If you never used Snipping Tool before, follow these instructions. If you're on a Mac, use the Mac equivalent of Snipping Tool. Click on your icon in your taskbar. If it's not there, go to your Windows search, type in Snipping Tool, open up the program. Click on the video option, then click on New. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in Snipping Tool, wait for the countdown. Hit the replay button on YouTube, let the video finish. Hit the red square in Snipping Tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.